Unit 3, Section 2. Today we're going to talk about characteristics of functions, specifically characteristics of the graphs of functions, which remember is just another way of saying the graphs of equations. So a couple of key concepts that we're going to start off by focusing on are the x and y intercept. The x-intercept of a graph is the x-coordinate of a point where the graph intersects the x-axis. And this occurs when y is equal to 0. In other words, you can find the x-intercept when y is 0. Conversely, you can find the y-intercept of a graph when x is equal to 0. And this is the point where it's going to cross the y-axis. So if you ever want to find the x or the y-intercepts, then simply substitute 0 in for the other coordinate. And that's a key concept for today. All right, let's look at example 1. Estimate the intercepts of the graph of each function. Well, instead of estimating, we're actually going to calculate it because of what we just talked about up above. We know if we want to find the x-intercept, this is where y is equal to 0. And we're given the equation right here in the problem. We're told that y is equal to negative 5/2 of x minus 5/2. So we're going to substitute 0 in for y and solve. So we get 0 is equal to negative 5/2 x minus 5/2. Now we're going to we're going to move numbers across the equal sign and solve for x. So we're going to add 5/2 over to the left side. And now we get 5/2 is equal to negative 5/2 times x. Well, in order to get x by itself, we're going to multiply by the reciprocal, which would be negative 2/5. So multiplying both sides here by negative 2/5 will eliminate that coefficient in front of x and leave me with just x is equal to negative 10 over positive 10, which is negative 1. In other words, the x-intercept is negative 1. So the point negative 1 over and 0 up is on the graph. Now you can confirm that by actually looking at the graph and seeing that it passes through that point, negative 1, 0. But the key concept is in order to find the x-intercept, substitute 0 in for y. All right, let's talk about finding the y-intercept. The y-intercept, remember, occurs when x is equal to 0. So let's substitute 0 into our function or our equation and find out what y is equal to. We get y equals negative 5/2 times x, which is 0, minus 5/2. Now, negative 5/2 times 0, anything times 0 is just 0. So it's eliminating itself here, and we get the y value equal to negative 5/2. That means my y-intercept is negative 5/2, or another way of saying that is negative 2.5. And you can see on the graph, it is exactly between negative 2 and negative 3. So my y-intercept is 0 over and negative 5/2 down. Again, highlighting the concept, the key concept that when you want to find your y-intercept, put 0 in for x. All right, let's take a look at the next graph here, which is the graph of a parabola. And we're going to look and find the x-intercepts first. Well, the x-intercepts are going to be found where y is equal to 0. And that's right along the x-axis. Now in this case, we're not actually going to put 0 in for y and solve for x. We're actually just going to take a look at it and find out where it crosses that x-axis. And it looks like it's at negative 2 and 1, 2, positive 3. So our two x-intercepts are negative 2, 0 and 3, 0. All right, let's find our y-intercept. Our y-intercept is down here on the y-axis. Again, remember, our y-intercept occurs when x is equal to 0. So let's actually substitute 0 in for x and find out what y is. When I put 0 in for each x in this equation, I will get y equals 0 squared minus 0 minus 6. Well, 0 squared is 0, 0 minus 0 is 0, and 0 minus 6 is negative 6. So my y-intercept here is 0 over and negative 6. All right, keep that in mind. A couple of key concepts here. Your x-intercept occurs when y is 0, and y-intercept occurs when x is 0. Let's take a look at a few more key concepts and characteristics of graphs of our functions. A function is said to be positive when the graph lies above the x-axis. So I'm going to highlight that zone here in yellow. And that is my positive part of my graph. Now, in order to find out my negative, let's just highlight this in a different color here. The function is negative when the graph lies below the x-axis. So that's this section of my graph right here. All right, so here's my little set of xy axes and a graph that goes through these different zones here, takes on these values of being positive and negative in those different zones. So where the graph is positive, it's above the x-axis. And you can see it comes up from being negative to positive and then back down to being negative again and then back up to being positive. And a function is negative when it's below the x-axis. So anywhere here in blue. Now let's talk about when a function is increasing or decreasing. When a function is increasing, it is moving up as x moves to the right. One way to think about this is a little roller coaster car that's on this roller coaster curve. And the roller coaster is always going to move from left to right. So here is my person in my little roller coaster. His hands are up and they're going up, or they're increasing until they get to this point right up here where they're going to be flat, and then they're going to be decreasing. So the roller coaster car will tell you whether it's going up, that's going to be increasing, or down, that's when it's going to be decreasing. So you can see from this function here, the graph of this curvy line, it will increase for a while, and then decrease for a while, and then increase one last time. Finally, another characteristic is end behavior. How does your function behave as x approaches positive infinity, way out here to the right, or negative infinity, way out here to the left? And one way to determine that is by taking a look at these ending arrows. You can see that this arrow is going to imply that this graph is going to keep growing larger and larger and larger. So for this particular graph, we would say as x approaches positive infinity, y is also going to approach positive infinity. Let's talk about the other end. How about as x approaches negative infinity? Well, looking at this arrow here, as x is getting smaller and smaller and smaller, you can see that this curve is going to continually decrease. So this curve, we would say as x approaches negative infinity, y also approaches negative infinity. All right, let's get some practice at those characteristics here. Approximate when the function is positive, negative, increasing, and decreasing. So this is a little bit of a tricky concept because it says when the function is positive. Now, we're not talking about a specific time, but when it says when, we're talking about a specific interval. Now, interval notation can be known as this sort of notation here. You're going to list your minimum value with the less than or equal to sign, and then the x value, because our intervals are always going to be taken on our x-axis, is going to be less than or equal to our maximum value. So we'll show you what we mean here. All right, so let's first of all find out when our graph is positive. Remember, positive is above the x-axis. So let me go back to highlighting this in yellow here so you remember what that looks like. Here is positive. And remember what negative looks like. We'll highlight that in blue. That's our negative below the x-axis. So everywhere down here. I'm not going to color it in for you. All right. So we want to know when. Well, it looks like my x interval here is right here at -2, and then out here at +3. So we would say anywhere where x is less than or equal to -2, or where x is greater than or equal to 3. That's where it's going to be positive. How about when it's negative? Well, the negative looks like it's going to happen between -2 and 3. All right, now let's talk about my notations here because I actually made a little bit of a mistake. We don't want all the x's less than or equal to negative 2. We only want all the x's less than negative 2. And likewise for 3, positive 3, or sorry, greater than 3. All right, and then another change I need to make is to where it's negative. Now here's the reason why. When x is exactly positive 3 and negative 2, those are my x-intercepts, and my y values are going to be 0. In other words, they're neither positive nor negative. So be careful, don't make the same mistake I did. Make sure your inequality symbols are just the less than or greater than ones. All right, let's talk about increasing and decreasing. Increasing, remember, means we are rising up from left to right, our little roller coaster car. So it looks like if we were to put our roller coaster here on the left side, we would be going down first. We're going to decrease until we get to this bottom point right here, which is known as our vertex, and then our car is going to increase again. So our increasing intervals are going to occur for all of our x's greater than 1/2. And our cars are going to be decreasing for all of our x's that are less than 1/2. Again, take a notice that I did not include that greater than or equal to, less than or equal to, because right here at the bottom, when x is equal to 1/2, my graph is actually flat. It's neither increasing nor decreasing. All right, finally, let's look at end behavior. As x approaches positive infinity, way out here to the right, what's happening to this arrow? It looks like it's going to keep shooting up, which means my y is also going to approach positive infinity. And as x approaches negative infinity, way out here to the left, what's happening to my arrow? It's continuing to go up as well. So as y approaches negative infinity, as x approaches negative infinity, that means my y is also going to approach positive infinity. It's going to keep growing larger and larger.